Hello viewers, in today's session we are going to discuss another important problem related to Leibniz integral rule. So here in this session we are going to discuss this problem where we are given a function f of x which is equal to the integral sine x to cosine x, and the integrand is t divided by 1 minus t square, and here we have dt, and we have to find out the derivative of this function, that is f of x, right? So to get the derivative of f of x, we are going to make use of the famous Leibniz integral rule, how to differentiate an integral when the limits of integration are some function of x. So here we see that the lower limit is sine x and the upper limit is cosine x, and both the limits are functions of x, right? So let us first quickly see the statement of Leibniz integral rule. That is, if we have a function, say f, which is continuous in some interval, that is a comma b, and if we have the lower limit as some function of x, that is u of x, and the upper limit is another function of x, that is v of x, and here we have a function, say f of t and dt. Then the derivative of this integral with respect to x is given by f of v of x. So first we will replace this t by the upper limit v of x, and then we multiply this quantity with the derivative of this upper limit, that is v prime of x. Then we have a negative sign, and then we replace this t by u of x. So we have f of u of x, and we multiply this quantity by the derivative of u of x, right? So this is our Leibniz integral rule, which we are going to use to get the derivative of this function f of x. So let us differentiate both sides with respect to x. So we have f prime of x, then we have d by dx of the integral from sine x to cosine x, and we have t over 1 minus t square dt. So if we compare this integral with this one, then we can easily see that u of x, the lower limit is equal to sine x, and the upper limit is that is v of x is cosine x, right? And the function f of t is given by t divided by 1 minus t square. So what we will do, we'll first write f of v of x. So here we have f of t, so we'll replace this t, all the t's in this function by cos of x, right? So we have first f of cos of x, then we multiply this quantity with the derivative of this function cosine x, that is d by dx of cos x. Then we have the negative sign, then we replace this t by sine of x, so we have f of sine of x, and then we multiply this quantity with the derivative of u of x, so we have d by dx of sine x. So now f of cos x can be obtained by replacing t by cosine x, so we have cos x divided by 1 minus cos square x. The derivative of cosine x is minus sine x, and then f of sine x can be obtained by replacing this t by sine x, so we have sine x divided by 1 minus sine square x, and the derivative of sine x with respect to x is cosine x, right? So let us simplify this expression. So we have minus cos x sin x, and from trigonometry we know that 1 minus cos square theta is equal to sin square theta. So we have sin square x, and here we have minus sin x cos x, and in the denominator we have 1 minus sin square x. So from trigonometry we know that 1 minus sin square theta is cos square theta. So here we have cos square x. So now we can cancel this sin x with this one. Here we have we are left with only one sin x. So we have minus cosine x over sin x, and then here we have this cosine x get cancelled with this one. So we have minus sin x over cos x, right? So let us simplify it by taking the LCM. So here we have sin x cos x, and then by taking the cross multiplication we have minus cos square x minus sin square x, and taking negative sign common we have cos square x plus sin square x divided by sin x cos of x. And again from trigonometry we know that sin square theta plus cos square theta is equal to 1. So here we have 1. So we have minus 1 over sin x cosine x, right? Okay, so now let us again simplify it by multiplying the numerator and denominator by 2. So we can now write minus 2 over 2 sin x cosine x, and from again from trigonometry we know that 2 sin theta cosine theta is given by sine 2 theta, right? So this is the double angle formula for sine function. So here 2 sin x cosine x is given by sine 2x. So we have minus 2 over sine 2x, and 1 over sine 2x can be written as cosec 2x. So the required derivative of the function f of x is given by f prime of x is equal to minus 2 cosec 2x. So this is our required derivative.